Hello and welcome everyone. Um, I'll be talking about exactly how can you build, what is the high level design of a chat application, and not just um, a normal chat application. It's like how are the um, contemporary chat applications that you see now, uh, for example, Slack or Discord, Messenger, Telegram, um, WhatsApp. How are these things built on a very high level? Which means you are not going to be building this chat applications for one or two users. You're going to be building it for billions of users. So we're going to be delving into this understanding of uh, what's gonna be the high level design of this big scalable modern chat application works, and how are we going to be able to build it? What are the tools that are needed, required in order to build this thing? So what happens in a chat application? Usually you talk, of course, we're so familiar with, but still, I'm going to give an example. For example, Messenger, what do you do in it? You talk to your friends. Um, or you could be enrolled inside a group of many friends where you give a message and that message gets sent to many of your friends. Oh, and you could also talk to personally to your friends. So messages get transferred privately between your friends, or it could be transferred between a group of your friends, right? So there's this group part, there's this single private messaging part, and how are these things handled for billions of users every single second, right? It's happening right now every single second. Messenger is handling, Discord is handling, um, WhatsApp is handling, Slack is handling, right? So that's what we're going to look from the absolute beginning to try to go to the depth to the best of my knowledge, and let's see how far we can go. Now, let's take a look at what's in here. Okay, so we're gonna make it right. In order to make any software application, what do you require in a software development? You need to follow. You usually follow a software development life cycle. So we need to do what? We need to do requirement analysis, right? Now, for a chat applications, there could be several features, and as we're going to be building the scalable ones, we would need some features, right? We can actually divide these requirements into two parts, functional and non-functional. Functional means that, you know, uh, if you don't have that feature, then you can't just call I mean, the essence is actually gone. If That's why it's called functional, right? Must have features. If it's not there, the essence is gone for the chat application. So it's just gone. And then there could be non-functional, which are definitely very, very decent. If you want to deploy it into the real world, you are definitely going to need this thing, right? So let's take a look at what could be the possible functional and non-functional requirements of a chat application. Now, okay, functional requirements, the must-have, I've just talked about it before, that, okay, you can pass one-on-one messages, you can send it, you can also receive it from your friend. You could also provide group messaging support. So you can create groups, you can add your friends, you can send messages to your friends that will be received by the group members, each and every group members. It could also have another important feature, which is last seen. So, I mean, users are not going to be around all the time, right? They're gonna be doing all sorts of other works and not just always be online. So how do you know? How does the system knows if a user is online or offline? Definitely, it has the dependencies on what sort of a perform or what sort of an action the system actually um, does based on a user is online and offline. Definitely, it's an important one. We're going to discuss about it. Um, the next one, of course, is usual login and authentication authorization services, which is very common. If you want to build a real world business centric application for billions of users, of course, security is a very important factor. Without it, the essence is gone. Anyone can jump into any other one's account, access anything they want. You wouldn't want that, and that's why you would add, the login and authentication. Okay, let's take a look at the non-functional. Of course, we're gonna have to build it, right? We plan to build it for the real world. We want the scalability to be right at the top of it. We want to be able to handle huge traffics of billions of users hitting your API, hitting your request. How you're going to be able to handle it? You're going to have to be prepared for that. How are these modern applications handling these things? We're going to talk about it too. Of course, it needs to be low latency. Uh, you see, these the real world um, applications. If you want to build a chat applications, it needs to have a low latency. You're messaging real time. You want to be receiving it real time. You don't want to wait for a while to receive messages from your friends, right? It has to be a real time messaging. So we have to consider so many options. We have to consider some decisions about what sort of a protocol that we're going to be using, right? So the next one would be availability, of course. Services should always be available. It's not like um, if service is down, of course, the conversation is going to have a very big disruption. So you don't want that, particularly in a chat application. Definitely, you need it. You definitely require this thing. Okay, now a very important step. Back of the envelope estimation. What in the heck is that? Okay, you're building a big application, right? A chat application, a scalable one, very big one. Of course, you're going to have to think about the cost. Cost not just in terms of money, but in terms of memory and how long you're going to be providing these services to the users, right? It has to have an estimation. And that's what we're going to do. As we're estimating billions of users, right? We care about um, the billions of users. We're going to be building our applications thinking about them and how much memories these people are going to take, right? Definitely, we're going to be thinking about it, and that's what we're going to do. Not just the cost estimate, not just cost estimations in terms of money, but of course, before money comes, we need to talk about memory too. You're going to be saving like billions of users' messages every single day, and just let's just roll into the calculation to understand about it more. Okay, let's say our user is 2 billion, 2 billion users. So, and also let's say each day 50 million users active, they talk to each other and do their work on these messaging chat applications. So we have 2 billion users and we have 50 million daily active users. Now, in each day, let's say that 10 messages, one user gives 10 messages to each of his or her, let's say, 4 friends. Just an assumption, we're just trying to estimate a rough estimation, right? So each day it would be like what? 2 billion messages, 2 billion messages a day, right? So each day you're going to be handling 2 billion messages per day. Now, for each and every message, let's say you use like 100 characters, right? Hello, good morning, whatever you say. Let's say that estimation is 100 characters. Each character, if each character is 1 byte, meaning you would have like what? For 100 characters, it's going to be 100 bytes. For 2 billion of these messages, each of them taking 100 bytes, how much is it going to be? 200 gigabytes of memory each and every day. You want to know how big is that? It is very big, you know. It is very big. We're going to have to handle it. So that's just an estimation for each and every day. 200 gigabytes of memory. Can you imagine? Each day. But we're also thinking about the future of our chat applications, which means we're going to maintain our chat applications for how long? Let's say the company decides that we're going to be maintaining these services for the next 10 years now. So if I want to provide this service, my chat application service, for the next 10 years, then I need about 200 times 365 times 10, meaning it's going to be about 7,300 gigabytes of memory. That's a big one, and you need that memory, meaning you need a lot of money. So prepare for that. You need a lot of money to build these scalable ones. So yeah, that's the back of the envelope estimation. That's just an estimation, rough estimation. The actual number is definitely very big, right? Uh, so uh, yes, you need a lot of money. Having a lot of money is the number one thing you require, actually, not these requirements. These requirements come after. You need a lot of money for that if you want to build a big one. Okay, um, let's take a look at the next one. So, how are we going to be? Now we're going to be actually talking about the protocol here. Uh, so, two users, okay, um, okay, they can talk to each other in several ways. One of the ways can be, you can imagine two users as two computers, each having an IP address, like IP pad 1, here IP pad 2, IP address 2, and they talk to each other independently like that. But the real question comes, of course you can build it. Two users talking to each other with their IP address, hitting each other with their IP address. You can talk to each other like that, which is also known as, you know, peer-to-peer connection. You might encounter this thing if you've worked you know, in a corporate environment where each company has their own network, own little networks, and each and every users, they talk to each other through this peer-to-peer, whatever, this rule. But is it feasible? Is it feasible to build uh, the connection between two users in a peer-to-peer manner for a scalable one? A scalable, when we talked about each day 50 million users talk to each other. Do you really want something like that? Peer-to-peer? Of course not. It's going to be a bunkers. It's not. It's going to fail right away. You won't be able to handle um, 50 million users talking to each other. How would you handle it? There has to be uh, a centralized sort of a thing, right? Daily active users 50 million. Um, you need someone to keep track of them. I mean, you can't just keep track of independent 50 million users talking to each other. If you want to build a system, you can't just independently track each of them. You need a centralized, something central that actually handles it. And so that's why you move to, uh, we move to uh, a different type of architectures, not the peer-to-peer one. Do you understand where the problem was? Peer-to-peer, you've had like what, independent connections between. So you're going to have independent connections, peer-to-peer connections of 50 million users. That is so big. Uh, uh, for each and every connection, you have to maintain their records. So it's going to be very tough. You need something central. So we move to the client and server architecture. We move here. Okay, yes, that is an option where the users, two users, will be communicating through the server, chat server. That chat server will be responsible for the scalability, grouping, uh, whatever functional, non-functional things that we talked about before. Is going to be responsible. Of course, there won't be one server. Of course, there will be multiple servers, right? I'm just showing this thing like that, but there will be multiple servers. Not one server can handle 50 million users a day. It's going to be like a you know it won't be possible. So you need multiple servers, of course, but the point is you need a central server to maintain these you know communication between the clients, different users, right? User end. So now let's move on to the next one. Okay, so we're going to be doing that, but now how the communication is going to happen. We said that the communication will happen between the user and the, or should I say, the clients and the servers, the chat servers. How do we exactly uh, yeah, so the connection between the centralized server and the clients, different clients. Okay, one of the communication protocol would be I could use HTTP, request response. But the thing is, if I want the central server to be my chat server, then uh, I need to know something fundamental about it. Is that in a client-server architecture, what happens is a chat server is not going to pass on request. It's going to pass on response. That's its goal. That's its fundamental thing. Um, so that is the essence of the client-server architecture. That a client will send a request, and a server is going to send a response. But in this situation that we've here, okay, let's say a user sends a message, a request to this chat server. Then if I want to build a chat application, that chat server needs to send that message, meaning it's going to have to pass on a request to a user, another user, the receiver. And then um, it would get the message, and then it would give the sender user the response. But you see, chat server does not uh, provide does not pass on request. Its sole purpose is to provide response on what it gets. So we have to think about something else, maybe modify this thing a little bit. Can we do that? Can we actually do that? Let's take a look at it. Yes, we can. There are a couple of ways that we can actually do. One of the ways is the pooling way. The pooling. It's called pooling, actually. What happens here? What happens in here? Um, we're going to take an example to understand the pooling process, the pooling communication process, how it's done. Imagine a user B, wants to send a message to user A. And, oh, sorry, imagine a user B will receive a message from user A. So what will user B, so purpose is user A is going to send a message to user B. So user B is going to wait for the response from user A. Will it wait from it directly? Of course not. It's going to talk with the server. It's going to talk with the server and ask the server, hey, did you receive a message from user A? If you have, just hit me. So that's what's going to happen. First, what the user B is going to do is it's going to build a TCP connection between um, the server, the chat server, and uh, when we send a request, user B sends a request, for example. Okay, it will send a request of, hey, chat server, did you receive a message from user A? Imagine that as an HTTP request. So it's going to create a transmission TCP. It's going to build a TCP connection. If you don't know what is a TCP connection, uh, please try to search on the internet to understand. I might be making videos about it later, but the purpose is to understand the process here. Okay, so user B is going to pass on a request, but before passing on a request, every time it sends a request to chat server, it will have a handshake between user B and the chat server. There will be a handshake between them when it sends the request. So let's say user A has not sent any message for user B yet. So what will the chat server return? The chat server is going to return, no, I have not received. That's exactly what happened. And when it provided the response, the moment it provided the response, the connection is closed. The handshake is not there. It's closed. It's gone. What would user B do again? It will send another request. Another request, that same HTTP request. Hey, did you receive the message? And then TCP, the chat server says, no, I did not receive it. Again, connection block. Connection is blocked. The TCP handshake happened here, canceled. TCP connection again happened here, and then handshake is canceled. So we're creating so many connections for just to see or to receive one message. So on and so forth. It's going to go on, and like that. Okay, user A did not receive, gave me message, uh, but I'm still gonna point in. I'm gonna hit the chat server again and again and again and again until at one point when user A actually sends a message to chat server, and chat server keeps track of it, and then after that, when user B, which he has been constantly doing it, hitting the chat server, hey, did you receive a message from user A? Did you receive it? And then it says, yes, I have. Uh, when the user A has sent the messages to the server. So yes, I have received, and then finally, user B got the message, right? This is called pooling process. So um, what do you think the problem is going to be? Of course, it's going to be a very big problem. I mean, think about it. One message we're trying to receive, we're sending so many requests. That is just hilarious. It's going to be if you want to use this communication protocol to build an application that handles 50 million users a day. That will be hilarious. You won't be handling. It's going to crash the moment you build it, right? So you're handling for heavy load, you can't use pooling. What you could use a process called long pooling. Well, that can be an option, but it's definitely not the best one, and we're going to talk about it too. Why it's not the best one, but let's talk about it is definitely an improvement over the previous one, which was pooling. Definitely a big improvement over the previous one. So we have long pooling over here. What was the improvement? It's the same as pushing. It's the same as, sorry, long pooling is also called pushing approach. So it's the same as the pooling approach, but there's a difference. The difference is it's not going to constantly, the main difference is that the user is not going to constantly send the request to the chat server and say, hey, did you receive message? Hey, did you receive message right away? Rather, it's going to take a while to send the next request. I can set that threshold by myself. So it's going to be a threshold of 1 minute. So let's say a user sends a request, hey, did you receive a message from user 2? And when the server says no, it does not directly send the request again. What it does is it takes 1 minute of threshold. The server, once you provide the message, once you provide the request, once the user provides the request to the server takes a threshold to provide the response. So let's say it takes 1 minute. Okay, I'm going to take 1 minute to give you the response. In this 1 minute, the server is going to take 1 minute. Okay, it's going to take, let's say if I have stored my threshold of 1 minute, so server will wait for 1 minute. In between these 1 minute, if user 2 provides him a message, it's going to give the response right away. So let's go through a workflow to understand exactly what's happening. We would understand more about if we have an example in our hand. So user 1 is providing a message to, okay, providing a request, okay, to the server. Hey, did you receive a message from user 2? User 2, server is going to wait for 1 minute and wait for user 2 to pass on message. Okay, he did not. He did not. After 1 minute, he did not send any message. So it provides a response. Hey, I did not receive the message. The TCP is gone. Connection is gone. Then what? User 1, or should I say this user, provides another request. Hey, did you receive the message? Server will wait for another 1 minute. In between, he's going to wait for the other user to receive the message. He did not receive the message, so connection is off. Let's say the third time when the user hits the request, hey, did you receive a message from the user 2, hits the request to the server and calls him, hey, did you receive a message from the user 2? And it's not going to give him response right away. Rather, it's going to wait, and after 30 seconds, suddenly user 2 provides the message to for the user 1. So what's going to happen now? The server, it's going to provide, yes, I have received the message from you, from the other user, and here's your message. So it can be called an improvement in terms of the request, right? In terms of the connection pool is quite less. For example, if we compare to the previous approach, you would see that, for example, let's say an estimation that in 1 minute, this user was sending many requests to the server, right? But rather, this approach, the pooling approach, long pooling approach, it's going to wait for 1 minute to give a response. So compared to the previous approach, the request rate is actually quite less, meaning the overhead is going to be very less, and meaning the TCP connection is going to be very less. So in that manner, of course, it's a cost reduction. It is an improvement, but it is not going to be dual purpose for a scalable application. You can't just use it. You can't just take 1 minute to provide a response to someone. Yeah, of course, it's going to be cost effective in terms of the connection pool and resource. You're going to save a lot of resource if you do that. A lot of connections are saved, but come on, 50 million users. You just have to build something that is real time, right? This is not real time. Come on. I mean, I'm giving the server, it's going to take 1 minute to give me an answer. This is not how you build, how we should be going for, right? Even if it, reduces the connection, but I want direct availability. I want a real-time connection. And for that reason, I will move to the final and what is used widely for modern applications, which is WebSocket. We're going to be talking about WebSocket now.